Hello and welcome to this presentation on enumerations, specifically flags enums. Now I'm assuming you've used enums and you understand how they work. And some people have also used the flags enums, but they don't quite understand how they work. So in this video I'm intending to show you, kind of go under the hood, if you will, show you how these enums work and how to be able to better understand and visualize how these things would work. Therefore you can then use them better in your applications. At the highest level, flags enums are enums that you decorate with the flags attribute, and you could either say just flags or you can say flags attribute as in all other attributes in C#. And the intent is for you to use these enumerations as sets. So typically an enum can have only one of these values of one of the elements here. So it could either be weekdays.monday or weekdays.tuesday and so on. When you decorate a enum with the flags attribute, you're kind of showing an intent where you intend to use this enum as a set. So in order to use an enum as a set, there are certain guidelines, certain recommendations, as well as certain requirements. So one of the recommendations is that when you define an enum with the flags attribute, it should be made a plural, so it's not weekday anymore, it's weekdays. The other guideline is that the first element should always have the name none and a value of 0. Now in enums, regular enums, when you don't define a value, it is assumed that the enum is of type int32 and the first element has a value of 0, the second one has a value of 1, 2, 3, 4 and so on. In the case of flags enums, you have to define each element with the value that's a increasing power of 2. So I'm going to show you what that means. The first one is always 0, so that's not a power of 2. The second one is 2 raised to 0. 2 raised to 0, or any number raised to 0, is 1. The second has 2 raised to the power of 1, which is 2. The next one is 2 raised to the power of 2, which is 4. Third one is 2 raised to the power of 3, which is 8, and so on. So all the elements have to have an increasing power of 2 associated to it. So in this case it's 64. Now in C#, well, let me show you how you would use that. So let's say I have a variable called days, and days is the set of weekdays of Monday, bitwise OR, and I'll explain what that is, weekdays of Tuesday. Think of the bitwise OR as if you're adding to the set. So it's like a OR operation, but it's adding on to the set. So days is nothing but Monday and Tuesday. Let's see the representation of this variable here. You can see that the debugger is showing this as Monday with the pipe symbol, or Tuesday. So it's the combination of Monday and Tuesday. Now, if I had not decorated this enum with the flags attribute, what you're going to see here is the value of 3 in this case, and I'll explain how it's becoming 3, which is because of Monday and Tuesday having the value of 1 and 2. It has, I guess, added on or added the value to be the value of 3, which is okay, except that if you wanted to use this in a string representation, where you say days.toString, you won't see it as Monday or Tuesday, you're going to see it as the value 3. So in C#, you don't need to define the enumerator with the flags attribute for things to work as you would expect. You do need to define each element specifically with a value, and in this case increasing powers of 2. But if you decorate your enums with the flags attribute, it kind of shows intent. In other words, if I saw an enumeration defined with the flags attribute, I know somewhere in your system you are using this enum as a set and not just a single, not just an enumeration. And it's a set because you're able to turn on multiple values, as you can see here. We've turned on Monday, or we set this days equal to the value of Monday and Tuesday, therefore 1 plus 2, which is 3. Now you won't find a 3 anywhere else. So the reason you're doing this powers of 2 is that the combinations of these will never be equal to any other existing value. In other words, I can keep on adding values here and you'd never get a conflict. So this number represents a unique combination, and so it's very easy to understand or figure out what this set is comprised of. And we're going to be spending some time just figuring out all those kinds of the set-based operations. Is this thing included in the set? Can I remove it from the set? If it's there, add it. If it's not there, put it back. Those kinds of set-based operations. One other thing you want to keep in mind here is that because in C#, in this case, this enum is by default an int32, you can have a maximum of 32 elements, excluding the none here. In other words, that's the first element, second. So you can have, this is only 7 elements here. You can have a maximum of 32 elements in your enumeration. Now, if you needed more, you could define this enum as a long instead of an int 32, and then now you would have the option to have 64 elements in this enumeration. We don't have the need here, so I'm just going to send it back to. You can also see that, let's say you went down to even 32, this number gets fairly large, and you have to do the sort of the calculations yourself. And then if at some point in time you have to inject an element in the middle somewhere, you got to shift all these values down and make sure it's all correct. Because if you get any of these values wrong, I mean, the compiler is not going to complain if I made this 15. But my set-based operations won't work exactly how I expected. So in other words, when these numbers become large, you've got to be careful to make sure the value you're assigning here is a correct power of 2 for the bit position in which this bit is sitting, meaning this is sitting in position 0, 1, 2, 3, 4, 5, 6. So this 2 raised to the power of 5 is what this value is. Right, so you've got to make sure that's 1, 2, 3, 4, 2. Okay, so it's 0, and this is 2 raised to the power of 5. Yeah. So there are ways to figure that out, or use this in a slightly different fashion, which will be sort of more intuitive, but it's a little more advanced to talk about right away. So we will talk about this towards the end of this video. So going back to the set, how did this happen, and what's happening with this bitwise OR under the hood? So I'm going to switch to, in this case, Word, and I'm going to represent Monday as a 4-bit number in this case, with the first bit turned on, which has the value of 1. So this is the position of 2 to the power of 0. This is 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. So in binary, Monday would be represented as this. Tuesday would be represented as that. Wednesday would be represented as that, and Thursday would be represented as that. So what you can see here is the bit. Every element here is nothing but the next bit that gets turned on. Of course, if we want to represent Friday, we would have to define this as a 8-bit number instead of a 4-bit number. So we just stick to Thursday for now, since it fits in the 4-bit scenario here. So, and I'm going to remove this Thursday from here, because what I'm trying to show you is how does days, which is nothing but the bitwise ORing of Monday, Tuesday, and Wednesday, equal to Monday, Tuesday, Wednesday equal to 7, right? So let's do an OR operation on these 3 numbers. So I'm doing it like a bitwise OR operation, which is this the symbol here, bitwise OR operator. So in the OR, in bitwise OR, what you have is if any one of these bits is turned on, the result is a 1. Okay, so in this case, no bits are turned on, so it's a 0. In this case, 1 bit is turned on, so in other words, it's an OR. Any one of these bits can be turned on. The same in this case, it's a 1, and the last one also 1. In other words, the representation of days, the set days, is nothing but the 3 bits are turned on in this case. And that's how you get the value of 7, but that's also how the compiler and runtime are able to figure out if you were to ask it certain questions, and we'll see how we would do that soon, to see if certain bits are turned on or not. So if days is represented as the combination of Monday, Tuesday, and Wednesday, let's say we wanted something called work days, or weekdays, no, workdays, let's call it workdays, then we, of course, we'd have to go through the entire set of, so Thursday and Friday as well. But if you had the need to have workdays represented across your application as a valid combination that you want to use in multiple places, you can actually define that here. So you could define workdays as nothing but the combination of Monday or Tuesday or Wednesday or Thursday or Friday, so all working days. And you could have holidays represented as Saturday, Bitwise, or Sunday. You could also have another combination called all, which is nothing but the workdays or holidays. Or you could just repeat all of these, including Saturday, Sunday over here, but I think this is a better way to do this. So, and it's important you do this so that you're not repeating these combinations if these combinations are something you use frequently in your application. And the advantage, or another advantage to this, is that these elements are not considered as part of your, in this case, the limit of 32 elements, because these elements are nothing but the combination of existing values. So you're not assigning additional values to these combinations, you're just using existing values from here. So they are not, I guess, eating away into your limit of 32 elements. You still have 32 minus 6 elements here. You're not having to consider these as additional elements. And so it becomes easy to work with. You could say, okay, I want my work days, in this case, I'll call this become, let's say I'm just got this variable called days now. That's nothing but weekdays and dot work days. Right? And so in one shot, you've assigned this variable to all your working days without really having to specify specific days itself. Now, what if you had something like this day is nothing but, let's say, Monday or Tuesday and Wednesday. Okay, so we start off with a set of days that's comprised of Monday, Tuesday, and Wednesday. So the representation of that set would be this. All right, so that's the set. And I want to ask the question, is Tuesday within the set? How do I do that? How can I ask in C# if Tuesday is part of this set? I can see clearly when I run this application that Tuesday is in there. But how do I know that? How do I figure that out in code? So I'm going to switch to, again, the bitwise operations here. So I'm going to move this down. So that's our starting. That's days. Okay, days is represented as, in binary, is represented as 0, 1, 1, 1, which is Monday and Tuesday and Wednesday. And I want to ask the question, is Tuesday in the set? The way you do that in binary is you use a mask and you end the mask. And I'll show you what that means. The mask in this case is, I'm saying, okay, I want to find out if this bit is turned on. So my mask will be nothing but this. Because I'm trying to find out if this bit is turned on here, I'm going to mask it with that bit. And then I do what is known as a bitwise AND operation. A bitwise AND operation, the result of this would be, again, just like an OR that says the result is a 1 if any one of the inputs, if you will, is a 1. An AND operator is that both inputs have to be a 1 for the result to be a 1. So this, of course, is a 0, this is a 0, this is a 1, this is a 0. So because these two are the only, these two bits are both turned on, the AND results in a 1. And all other cases, the AND results in a 0. So this is days. This is the mask that is Tuesday. The result is Tuesday, right? So if I want to ask this question in C#, this is how it's going to look. And it's going to be a bool return in this case. I'm just going to specifically say it's bool so there's no confusion. So let's call this Tuesday is in set, and it is nothing but days bitwise ANDed, so it's a single ampersand, just like this is a single pipe. This is a single ampersand, bitwise ANDed with weekdays dot Tuesday. That's my mask. And if this mask, days ANDed with this mask, is equal to weekdays dot Tuesday, then this should be set to true. It's kind of like the same thing over here. We're saying days ANDed with the mask of Tuesday should be equal. If it's equal to Tuesday, which in this case it is, then this bool variable should be set to true. So let's run that and see that. So you can see it's set to true. Let's check our theory here. What if it was Thursday instead, right? So we're, in this case, we're seeing if the set contains the element Thursday. If we run this again, you'll see it's false. And if we were to do this in bitwise operation, Thursday is nothing but the next bit's turned on. So in other words, we are seeing if we were to, the mask would be this, right? And if we were to AND this, you'd see that that's a 0, 0, 0, and 0. In other words, nope, the bit's not turned on. So the ANDing is giving us the opportunity to check against the masking, if you will, is allowing us to check against the bit we're interested in. And if we result in the bit we're interested in, then that bit is turned on. So for all the bits in this case that are potentially turned on, by using a mask of your choosing, like in our earlier case with the Tuesday, we don't need to know if these bits are turned on. All we're interested in is this bit turned on, and that's the mask we're using, and that results in that. So again, if this was Tuesday and this was also Tuesday, the mask is Tuesday and it equates to Tuesday or equals Tuesday, then the bit is turned on and it results in true. So that's the bitwise AND operator. What if you have start with a bunch of days here and you want to move? So let's say we start with Tuesday. I'll just add this as Tuesday, and again just make this Tuesday. So Tuesday is in set. This should equate to true. What if I did this? I said days is XORed. Let me talk about XORed. Weekdays dot Tuesday. What I'm saying here is that this days is equal to XOR dot Tuesday, and what XOR means is from this set remove Tuesday. Okay, that's the XOR operation, and we look at the way it works in binary. So whatever the days is, whatever the set is, remove Tuesday from it, and it doesn't matter if Tuesday is in the set or not, it'll be removed. In other words, you won't get an error because you're trying to remove Tuesday from a set that doesn't have Tuesday in it, so you don't have to actually know upfront if Tuesday is in the set. The XOR operation says if Tuesday is in the set, take it out. So then this should return result in a false, right? Because you start off with Monday, Tuesday, and Wednesday in the set. You then remove Tuesday and you check to see if Tuesday is in the set, and that results in a false, right? So here you can see now day is just Monday and Wednesday. Tuesday is not there anymore. How does this work in binary? So we start off with Monday, Tuesday, and Wednesday, and we want to remove Tuesday. So this is the same. This is Tuesday. We want to remove this Tuesday, and the way we do that is this is not gonna. Okay, I'm just gonna put in Tuesday again, and I want to do a XOR operation. So the XOR operation, XOR stands for exclusive OR. So the inputs have to be exclusively ORed. In other words, this is 0. 1 OR 1 is a 1. 1 and 1, meaning in this case a typical OR operation, this would still result in a 1, but it has to be exclusively OR, meaning only one of these bits can be turned on for the result of an XOR to be turned on. So this will be a 0, and this will be a 1 again. So an XOR operation is allowing us to remove from the set. So we're saying take this, and if it's in the set, remove it, and the result is this. So we start off with Monday, Tuesday, and Wednesday. We XORed Tuesday from the set. We are left with Monday and Wednesday, And so here you have this day is, in other words, Tuesday does not belong in this set of days here. One other thing you can do here, I'm going to leave this like this, but in C#4, they introduced a method that made this easier. So you could actually just say days dot has flag Tuesday, weekdays or Tuesday. So that's another way of doing the same thing. Right? I just thought it's easier for you to understand what's going on behind the hood, and for me to show you the binary operation. It would be easier for me to show it to you like this. But once you understand it, of course, you can just use has flag, and you can do it that way. Behind the scenes, I'm sure that's exactly what it's doing. So we've covered the bitwise OR. We've covered just now we've covered the XOR operation, and we've covered the bitwise AND operation. Now, the last thing I want to cover here, at least in binary form, is this idea that Monday is this bit turned on, Tuesday is this bit turned on, Wednesday is that bit turned on, let's say Thursday is this bit turned on, and so on. So as we are adding powers of 2 elements, or values of the power of 2, all we're really doing is we're shifting the bit, in this case, to the left, 1 position to the left. We're turning on the bit. Let's say in this case, this bit is turned on, then you shift it 1, it goes here, you shift it 1 more, it goes there, you shift it 1 more, it goes there, and so on, all the way up to 64 if you had this enum was this 64-bit integer. So this goes back to this representation. How would I represent this as these numbers become larger? What's the way for me to do that? In C# you have the left shift operator, which looks like, and I'll show you what that looks like, but essentially what it's saying is 1 left shifted 0, okay, and this would be 1 left shifted 1. This would be 1 left shifted 2. So you can see now, as we're moving through this, that this would be a lot easier to maintain, if you will, because all you really have to manage here now is make sure that the left shift is shifting in an increasing numeric fashion. So that's 0, 1, 2, this has to be 3, this has to be 4, this has to be 5, this has to be 6. So all you're saying is start with a 1 and shift it to 0 left, meaning the first bit on the right, the least significant bit is turned on. So that's 1 left shifted 0 times. The same 1 left shifted once goes here. Then this 1 left shifted 3 times, meaning start from here and left shifted 3 times, it goes there. Start from here again, left shifted 4 times, it comes here, and so on. So this is a lot easier to maintain, because if you were to if you need to inject an element, say right on the top here, and you had 64 of these elements going down, you don't need to know the resulting value of that power of 2, and it's very easy for you to determine if these are in the proper sequence. You're just saying 0, 1, 2, 3, 4, 5, 6, 7 up to 64 or 63. So that's the other way to do that. Now that you understand somewhat bitwise operations, and especially the bitwise representation of these elements, it's easier to understand the shifting aspect. So where do you use set-based enums? Of course, in some cases, I'm sure some people have immediately figured out, oh, I could use this here, I could use this there. Some cases would be where you have a set of business rules that apply to certain criteria. So I'll keep it simple. Let's say certain rules apply to combinations of days a week. This rule applies to Monday and Tuesday. So you could have these rules registered for combinations of enums. And then based on the day of week, you can say, give me all the rules that apply to today. And immediately you can go through your collection and figure out which rules apply to today because of the combination things. You can have states, right? So you can have some rules that apply to certain states, some rules apply to all states, some rules apply to all states except these 2 states. So you could have, like you have if this were states, you could have one that represents all states, and when you register the rule, you could just say this rule applies to all except, as we did earlier, all except Tuesday, or in this, let's say all except Virginia, or all except Virginia and Maryland. And so the ability to define a rule, a business rule, let's say, and then associate it to a combination of, or combination of enums or multiple combinations. You can have a rule that applies to, let's say in your system you have rules that whose criteria are based on the state, let's say the country, the company, the day of the month, what have you. The various criteria that rules are dependent upon are all, let's say, enums or flags enums. So you can say, okay, this rule X applies to states so and so, countries so and so, and days of the month so and so. And then you could, when you have to execute the rules, you can say, okay, now give me all the rules that apply to this country, this state, and this day or month. And you can easily extract out from your collection of rules the rules that apply to that combination of criteria. So it's just one of the ways in which you can use flags enums. Of course, it does not be that complicated. It could be simply things like this, like days a week, or let's say security roles. You could say this method you can be executed by anyone in let's say super user and user roles, and you can say this method is executable by anyone, all users except guest, and so on. So you could have some of these combinations very simple, but the flags enum gives you this ability to very easily explain or define criteria, set-based operations or set-based criteria for certain things in your system. So I hope this has been a useful and informative video. I'll see you next time.